Let me grab those real quick again. But in series, it just adds, right? Like the distance increases. So it's 1 over.
There are two questions. Well, actually three. What, why, and how. So
right.
In this situation, you're solving a problem, so it doesn't matter why. What matters is what to do and, well, how to apply it. If you have two capacitors connected in series, in that case, you use inverse capacitance.
Mm-hmm.
This is just something you need to remember, right?
Right.
And if you have two capacitors connected in parallel, the equivalent capacitance is just the sum.
Right.
This is what I will cover tomorrow right at the beginning.
Mm-hmm.
But you know that already.
Mm-hmm.
The question is now how to apply it.
Right.
If you look at this system, you need to make a statement about, well, this is C3. 3 different pairs of capacitors, C1, C2, C1, C3, C2, C3. And for each you have to make a statement. What choices do you have? You only have 3 choices. Capacitors may be connected in parallel, in series. I don't know what symbol. There is no symbol. I need to invent. I don't know. Whatever. And neither. These are all the options. So for each of these 3 pairs, you have to make a statement. So C1 and C2. Can you say something about them? How?
C1 and C. Oh.
Yes, C1 and C2.
They're parallel.
Parallel.
So it'd be additive.
So you're correct. What about C1 and C3?
So they're in series?
No.
Well, with C1 and C2.
C1 and C2 are in parallel, as you said, and that is correct. But you made a very common mistake. C1 and C3 are neither.
Oh, okay.
If you could take scissors and cut this wire and remove C2, that would make C1 and C3 in series. But by adding an extra element, you break this connection into nothing. It's neither. So you cannot use any equation for either of these, C1, C3, or C2, C3. But you could use this. This is the only equation which makes sense. That means this is what you have to use now. And that means you can replace these two with only one. But that one must have a very specific capacitance, right? Which one? Which capacitance should it have?
It would be the sum of the...
Exactly.
Yeah.
You know that. So now you could have done it physically by physically replacing 2 devices with one, or you could do it mentally using your imagination. You can imagine that you have replaced 2 capacitors with one, but this new capacitor will have new capacitance. And this will be your new circuit. Now it is simpler because it now has only 2 elements. This is not the old circuit. This is a new circuit. But this is an equivalent to old one. But now this circuit tells you that with these 2 capacitors, you can use a rule. Which rule?
That they're in series.
Yes. Absolutely right. Which means now you can replace these 2 with only one, C1, 2, 3, and it must have capacitance, well, hence, which should be calculated using this rule. This is your final system equivalent to the initial system. What does it mean equivalent? It means if you apply to this system the same voltage as it's applied to this whole system, you will get the same charge distribution, the same total energy. Yes.
So how do I break that down then into the capacitors with like, so they all have the same voltage applied, right?
No,
No.
that's a different question. First of all, let's erase this. Each capacitor may have its own charge. Each capacitor may have its own voltage across. In general, but because these capacitors connected in a special way, you know that for these two capacitors, the voltage is supposed to be the same, because voltage is just potential difference between these 2 points, same voltage.
Okay.
But if you measure voltage, potential difference from here to here, the total one, I think that is given to you.
Yeah, it's on mine, it's like 1.57.
Doesn't matter.
Right.
You need to know that this total will be the sum of these two, from here to here, plus from here to here. So total will be equal to V1 plus V3, or V2, because they're the same.
Okay.
What else do you know? Well, you know that equivalent means this capacitor, which you use to replace these two, must have the same voltage and the same charge as these two. That's what equivalent means. So you can say that this charge Q12 has to be equal to Q1 plus Q2. But the voltage should be the same as before, V1, and this is the same as before, V3. And now if you go to this, well, you have the original voltage across the whole system, because it's between the same original points, A and B, A and B. Again, what is voltage? Potential difference between 2 points. So you have point A, point B. If you measure potential difference between A and B, it's always the same number, no matter which circuit you would use. It's only based on the points. But now here, this charge Q, what should it be equal to?
That's the total charge held in all three capacitors.
No.
No?
No.
Okay. It's, I mean, we can relate voltage, capacitance, and charge, right?
Of course you will, and you will have to. But you need to understand what does word equivalent means.
Oh, it's the same between, yeah.
It means that if you use this single capacitor instead of these two, this charge should be equal the same as this. When this voltage is equal to this, that's what it means. So this charge Q is actually just Q3, and actually this Q3 is actually equal to 1, 2. Because when capacitors are connected in series, the charge has to be the same. Why?
Okay.
Well, because if you connect them in series, basically what you do is you're moving electrons from one plate to another. So the charge here should be equal to the charge here times -1, but that means this charge should be equal to negative, same as here, and this same as here. So in the series, they all have to have the same charge.
Okay.
You see how many connections do you have? Plus, as you just said, you can write Q1 equals C1 V1, Q2 equals C2 V2, Q3 equals C3 V3. Now Q12 equals C12 V1. Q3 equals C123 V. Did I miss anything? No, I think that's it.
So Q12 is C12 times just V1 because it's the
Yes.
same. Okay. Just double check.
Well, again, to be absolutely exact, you should have said this potential difference equals V12, but it also equals V1 because it's
Right.
because it's equivalent to original potential difference.
Okay. Thank you. I'll work on this.
Yes, and I remember from the past, because numbers are not very convenient, like very small numbers. In order to get the answers, you see, you need to keep many digits because
Okay.
people have it done correctly, but they didn't keep enough digits, and the answer was not just accurate enough for the web assigned to accept it.
Okay. Sounds good. All right. Thank you.
Sure.